For my calculus commercial, I chose Newton's law of cooling as the topic and applied it to crime scene investigation. A couple hundred years ago, a smart man by the name of Isaac Newton somehow figured out that the rate of change in temperature of an object is proportional to the difference between the temperature of the object and the temperature of its surroundings. In this case, K is the heat transfer coefficient, which varies depending on the object and circumstances. Now, in a crime scene investigation, they might want to figure out the time at which someone was killed, and they can do so using the temperature of the body. However, our equation is for rate of change in temperature, not for actual temperature. So what do? We integrate using separation of variables. So if we let T equal temperature of the object, M equal temperature of the surroundings, and little t equals time, then we get the rate of change in temperature is equal to K times the quantity M minus big T. From here, we divide both sides by M minus T and multiply both sides by D little t. Then we integrate to get the natural log of the quantity M minus big T is equal to negative K times little t minus C. Then we set both sides as exponents to a base of e. Then we get the absolute value of M minus big T equals e to the power of negative K little t minus C. Since the object will be cooling in the following situation, M minus big T is negative, so the absolute value is the opposite of M minus big T. Then we isolate big T since we want the object's temperature. We let e to the negative c be equal to a while recognizing this value is the difference between temperatures. Finally, we get the following equation, which lets us find the temperature of an object at any time using T sub s for surrounding temperature, T sub o as initial temperature of the object, and the constant K. So say a corpse is found in a hotel room at midnight and the police suspect it was a murder. The body is 80 degrees Fahrenheit at the time of discovery. The thermostat has kept the room at a constant temperature of 60 degrees Fahrenheit. 2 hours later, the corpse is 75 degrees Fahrenheit. It is also worth noting that the average temperature of a living human body is 98.6 degrees Fahrenheit. Now we isolate K because we still need to know its value. We use the temperatures observed and use 2 hours for little t to get a heat transfer coefficient of 0.1438. Now we isolate little t and use our K constant, the average temperature of a human body, the first observed temperature of the corpse, and the temperature of the room, to finally get T equals negative 4.57 hours. 4.57 hours before midnight means the person was killed at around 7:26 p.m.